Hello everyone, welcome to our video on atomic structure basics. Now, what is an atom? An atom is something that makes up everything. If it exists, then it is made of atoms. The periodic table of elements lists all of the different varieties of atom, if you will. Atom means uncuttable or indivisible, and it cannot be broken down and be the same thing. So if you take one atom and you split it, it is no longer that thing. So for an example, iron. Iron is an element on the periodic table. If you break it down, then it's not iron anymore. And an atom's identity, if it's iron, oxygen, carbon, any of those things, does not change in a chemical reaction. Now, what about the structure? So this picture is not 100% accurate to what an atom actually looks like, but it's a pretty good representation of the overall structure. It has a nucleus, and it's where the majority of the atom's mass is. It's very, very dense, and it has protons and neutrons that live there. Electrons live in shells, or like layers or clouds, at different levels on the outside of the nucleus. An atom is neutral, so think of magnets. It has no overall charge. They're canceled because there is an equal number of protons and electrons, which we'll get to in just a moment. If there's not an equal number of protons and electrons, then the atom becomes an ion, which can be positive or negative. So again, the three basic parts of an atom is the proton, the neutron, and the electron. A proton has a positive charge. Think of it as +1. A neutron, so proton is positive. A neutron is neutral, or it has no charge. Its charge is 0. And an electron is negative. It's -1. The protons and neutrons are located in the nucleus, and the electrons are orbiting the nucleus in the electron clouds. The mass of a proton is 1 AMU, atomic mass unit. Don't bother trying to figure it out in grams. It is a very, 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 very small number, so we just use AMU. The same thing with neutrons is 1 AMU, or atomic mass unit. Now, the electrons do have mass, but it's so small that it really doesn't affect the mass of the atom. You would need something like 1,000 electrons to equal the mass of one proton, so we basically treat the electron as though its mass is 0. So some fun facts. All elements have different numbers of protons, and the proton determines the identity of the atom. If it has 5 protons, then it's one element. If it gains a proton, then it changes to a different type of element. Neutrons. Atoms can have extra neutrons and not really affect much except for the mass. And stability. Neutrons are really there for stability, and they can actually have extra neutrons or lose some, and that's called an isotope, which we'll get into a lot more later. Electrons, because they're outside the nucleus, they're actually very easy to gain or lose, and that's how ions happen. The electrons are happy to bounce from one atom to another, really whatever makes the atom most stable, and actually just brushing your hand along a surface, you're transferring electrons. So a couple definitions. Atomic number is something that you see on the periodic table, and that is the number of protons in an atom. Again, we said 5 protons. That means the atomic number of that atom is 5. The atomic mass is the average masses of all isotopes of an element. So that one's a little tricky. So different isotopes have different masses because you add a neutron and it adds mass. But some of them are going to be more stable than others, or found more commonly. So it's taking the average amount of that stuff that's out that we actually find in the world and kind of influencing that. So it's not usually a nice whole number. It'll have a lot of decimals afterwards. And mass number is the sum of protons and neutrons in an atom. So for an example, we'll go back to our 5. If it has 5 protons and 5 neutrons, then its mass number is then its mass number is 10. If it has 5 protons and 6 neutrons, so now it's an isotope, then its mass number will be 11. Ion. If the protons and electrons are not equal, so if there are more electrons than protons, it'll be a negative charge. And if there are fewer electrons than protons, it'll be a positive charge. They're both 1, so proton is +1, electron is -1. So they cancel each other very nicely. There's no weird fractions or anything. If there's one extra electron, then the charge is -1. If there's one fewer electrons, then it's +1. And an isotope, again, an atom with the same number of protons, but different numbers of neutrons. Now, really the key thing to kind of wrap your head around is this chart that we just went over. You want to know the charges, you want to know the locations, the mass, and really the fun facts are talking about what happens if the number of those change in the atom. What happens to the atom if you gain or lose a proton, gain or lose neutron, gain or lose electron. If you can really wrap your head around this chart and what happens if those numbers change, then you're going to be in good shape. All right, everyone, have a great day.